From the 7 models that are sketched in the paper, we have seen the informal one and 1, 2, 3 formal ones. In the last part, I'm going to discuss a bit 2 other models. I will not go into the details of this model here. Let us very shortly discuss this model, which is about relational database systems. Let us jump to the class diagram over here. Well, as you see here, it is kind of an extreme model for the library. Before, we have seen 3 different classes, a class user, a class copy, and a class book. And now we only see a single class here, a single class called library. And to be even more extreme, the class library has only one attribute. However, this attribute is highly structured. And I was referring to the UML and OCL collections already from time to time. And this is, so to speak, an example of an extreme use of the OCL collections. Probably I've not mentioned yet that the OCL collections can be used in an orthogonal way. That means you can combine the collections in an arbitrary way. You can take one collection and put it as a kind of low-level collection into another collection. And this is what we have, what we see here. We have not seen the tuple construction. Tuple is another option in OCL and UML to build collections. Those who are familiar with relational database systems, just look at the user part here in the first line. So you can think of that in a relational database system you can imagine a table that is called user, and in the table there are tuples consisting of a name and an address. And you can think of a table book where you have tuples with titles and the publication year. So a table in a relational database system is a set of tuples, and this is formally reflected here. So book is something, namely a part of a tuple. Book is a thing which has the type set of tuple, and the tuples have the components title and year. And analogously, a user is a relation. User is a set of tuples, and the tuples have the component name and address. And so in total, there are 4 relations over here, and these 4 relations, or these 4 tables, are put again into a tuple as components into a tuple. And this is the attribute DB standing for database. So the modeling is sort of extreme because everything what is in the object-oriented style distributed over several classes is put in a very centralistic way here into one single attribute. And we have only one single class, and the class will only have one instance, and the operations On the other hand, the operations have a one-to-one correspondence to the operations that were available in the object-oriented models. Namely, we have for the user we have the init, the borrow, and the return. For the copy we have the init, the borrow, and the return, and for the book we have the init. And so these are operations that manipulate this single attribute here. I will not go into the details. Just I want to give this impression that in modeling you can also do these kind of extreme things. Another model that I want to discuss is this one. The model is called inf2super, and this has to do with the following fact. Let me jump back to our original starting model, and we have had 3 invariants there which had the same structure, more or less. We have had originally we have had in the user class the invariant name is key. We have had in the copy class the invariant signature is key, and we have in the book class the invariant title is key, which has also the same structure. The observation here is as follows. The formula for defining this invariant is the same for all 3 classes. Here we have, when we have two different users, U1 is unequal to U2. 2 different users implies these different users have different names. When we have 2 different copies, this implies the signature of the different copies are different. And as I said, for the title, it is the same. So the idea in this model, where are we? Here we are. The idea in this model is to factor out this behavior, these 3 different invariants, and which have the same structure, and to formulate these invariants only once and make use of this one formulation in the concrete classes, in the concrete cases. And therefore, what is done in this model here, inf2super, there is one abstract class. An abstract class which is called keyed, provided, or you can think of the name of the class provided with a key value. And this is an abstract class. An abstract class is a class, so you see here, first of all, it is a generalization of user, copy, and book. And an abstract class is a class which does not have objects, which does not have instances. In formal terms, I could have written abstract here. The UML representation for abstract classes is also that it is that the name of the class is written in italics. This abstract class does not mention anything from the concrete classes here in the lower part of the hierarchy. This abstract class uses OCL-USE, and it uses Boolean. OCL-USE, the most general class that is available. And the abstract class simply declares, well, in order to be a keyed object, you have to have an operation. Yeah, you see here no attributes, but only two operations. You have to have an operation that is called key value, and that gives you an OCL-NE. And in order to be a keyed object, you have to have an operation comparable to. That's an operation that is performed on an object that receives another object as a parameter, and then the decision is taking whether the receiving object is comparable to the parameter object, and the operation says yes, I'm comparable to that object, or I'm not comparable to the object. And well, to cut a long story short, is that these two operations are made concrete in the concrete classes, that in the specializations here. So user has a key value, copy has an operation key value, and book has an operation key value. User has an operation comparable to, copy has an operation comparable to, and book has an operation comparable to. And speaking informally, the operation key value in class user will be that the class user says my key value is my name. In class copy, the key value will be the signature. So a copy says my key value is a signature. The book says my key value is a title. And concerning the operation comparable to, the user says I am only comparable to user objects. The copy will say I'm only comparable to copy objects, and the book object, in the class book, it will be said I'm only comparable to a book object. And the general formulation now for the constraint, here you see the general class keyed. That's a general definition of the operation keyed, which returns a key value, and it says it's something undefined. And comparable to is also undefined. And in the general class, the constraint, in the abstract class, the constraint is formulated. The constraint says different objects, different keys. And you see here now sort of a generalization of the three invariants that were used in class user, in class copy, and in class book. This invariant has the same structure as the three concrete invariants. That's a self, and that's universal quantification here over the self too, and it says the invariant says when I have a self and a self 2 and self 2 are comparable to each other, this implies the key value of the self and the key value of the self 2 have to be different. In the original, in the concrete classes, we had U1 unequal to U2 implies U1 name unequal U2 name. So this formula is a generalization of the three concrete formulas of the invariants, and the advantage here is that the constraint, the invariant, is only formulated one. On the other hand, what we have to do, we have to establish the connection between the concrete classes and the abstract classes, and the connection goes as follows. So for example, in the user class, we will define now the operation. We will define the operation key value. In the user class, we say the key value is a name. And we will define in the user class, the user will say, I am a user object. Self will only will say, I am only comparable to an object O if it is an object which is of type user. We can jump into, this is the paper part, we can jump into the appendix. We will see it slightly in a better form there, where we have the infs to, that's the relational database system, that's the infs to super. So again, in the appendix, we see here, this is the general constraint. These are the abstract operations, key value and comparable to. And here now we see the class copy and the class book. And the class copy declares my key value is a signature. The class book declares my key value is a string. And the class copy declares I am comparable only to objects which are of type copy. And the class book says I am comparable only to objects of class book. So the operations key value and comparable to are implemented differently in the concrete classes. This more or less concludes our journey through one example, namely this library example. We have seen the library example, the library model in different styles, partly in different in extreme formulations. We have seen an informal description. We have seen two formulations which were playing around what to formulate as invariants and what to formulate as pre- and post-conditions. We have seen a formulation where we did not use associations at all. We have taken what was put into the associations and have formulated as attributes. We have seen a very extreme formulation with only one class and one attribute in form of a relational database system in first normal form. And we have seen a formulation where we have built an abstract class in order to consider three invariants that were distinct invariants in the starting model, and we have formulated this invariant only once in a superclass in an abstract class. So this completes the overview on these different formulations of the same model. My aim with showing these different models is that one gets the impression there is no, so to speak, canonical formulation of a model. When you have an informal description, you can come up with quite different, quite extreme solutions, and there are always alternatives on different levels. So this formulation went into the direction of formulating, of using relational database systems. This formulation went into the direction of going into the direction of a programming language like Java. And these two formulations here, we got rid of redundant invariants and formulated an invariant only once. Here we got rid of invariants and formulated everything as preconditions, and you can even combine these different sort of transformations that you're doing. So in particular, in order to go into the direction of a programming language in implementation, you can combine the fact that you take the associations and you formulate them as attribute, and the fact that you remove the invariants and formulate them as preconditions. You can combine these two different transformations. You can combine these models in order to go into a programming language direction.